everyone. In our previous lesson, we talked about different kinds of data classifications, and then we talked about the measurement scales. Now we're going to shift focus into another critical area of statistics, that's how we collect the data in the first place. There's several different basic sampling methods that we're going to learn about. I'm sure there's more methods out there than this, but this covers the basics. So, and it's very important to make sure we pay attention to how we sample our data to make sure that our results are valid. So looking at our definition box, I have some of the basics here. The first one is simple random sampling. In my opinion, this is the most ideal way to sample because every single individual in the population has an equal chance of being selected. So think of it as like putting names in a hat, and everybody has an equal chance of being picked. That is a simple random sampling method. It's fair, it's unbiased, it's statistically sound. In a large population, it can be hard to do, though, without the help of software or like a number generator. So like if you're dealing with a huge population, it's not always easy to so-called put the names in the hat. So when you're doing a simple random sampling method with a large population, typically we use some kind of software or number generator. The next method is called stratified. I want you to pay close attention to the differences between stratified and cluster sampling methods. These seem very similar, and it's easy to get these confused. So I'm going to make sure that I go through these in detail with you. Stratified is where you take the population and you divide it into subgroups. So every item in the population is in some kind of subgroup, and those are called the strata. And then you take a random sample from each of those groups. So, for example, maybe I have a population of students, and I want to make sure I have an equal amount of males and females. So I would split the population up into two groups, males and females, and then maybe I take 50 from each group. So the strata would be the groups, the females and the males. So stratified is when you break the population into groups and then pick random samples from each group. Cluster, let's skip systematic for a second so that we can compare stratified and cluster. Cluster is very similar, where you take the entire population and you break it into groups. Then what you want to do is, when you're doing a cluster sampling method, rather than picking some from each group, you're going to pick the entire group. So an example of cluster would be if I took all the students on campus and I split them up by year: freshman, sophomore, junior, senior. Okay, so freshman is a group, sophomore is a group, junior is a group, senior is a group. And then I randomly pick two entire groups. So cluster is you pick that whole entire group. So when I go to pick my sample, let's say I pick all freshmen and all juniors, and everybody that's in freshman or junior group is part of my sample. So that is the difference between stratified and cluster. Stratified and cluster both take the population and split it into subgroups, but that's where the differences happen. Stratified is where you pick a few from each group. Cluster is where you take one or two or however many of the entire groups, and that goes towards your sample. All right, now let's go back and look at systematic. Systematic is every case item is selected from a list or sequence. When I think about the systematic sampling method, I picture a conveyor belt, and I picture some item on the conveyor belt that's coming down every 20th item. And those items that I pick go into the sample. But the key to this is that the number of items between each sample that you pick when you're looking at them in a list or a sequence is the same. It's always going to be the 10th item, or it's always going to be the 20th item. That's systematic. So think about systematic as being on a conveyor belt, and you pick every 5th item or every 3rd item. Okay, now let's look at convenience sampling. This is when you collect your sample by taking either people or items, whatever it is that you're collecting, and you find the easiest way to reach or pick those items. So maybe you're standing outside a cafeteria and asking the first 10 people who walk by. So that would be convenience, whatever is the easiest way to do it. Even though this is a quick and easy way to sample, it can lead to bias because you might not get a good representative sample. So, for example, if you want to do a study on eating healthy, but you're standing outside of a health food store and you're picking people as they come in and out to ask questions and survey them to collect data, that's going to lead to bias because you're not getting a good representative sample of a population of people. You're only getting the people that are walking in to a health food store, so most likely those people are going to be eating healthy. So that might cause some bias in your study. So although it might be an easy way to get some information, it's not necessarily always the best. Now, the last technique that we're going to talk about is called random sampling. Now, it looks like we may have already covered that. Notice we have simple random up here, but we have random down here. There's a difference between these two, and often students get these mixed up as well. Simple random, that means every single individual, and actually I should have added in here, make a little note in here, add in here, not only does every individual have an equal chance of being picked, but every possible sample has an equal chance of getting picked. However, if you're just talking about random and it's not simple random, then you can randomly pick items for your sample, but it's in an impromptu way. It's not structured, it's not planned, and it's not necessarily giving the members of your sample an equal chance of getting picked. So think of this as when individuals are chosen randomly but without structure. It's like walking through a mall and approaching people at random. It's not as carefully planned as simple random, where every individual in every sample has the equal chance of being picked, but it's still randomly being picked. Okay, let's look at the first couple of examples. Example 1, it says identify the sampling method. A teacher puts all students' names in a bowl and selects 5 without looking. So let's think about this. Every student has the same chance of being picked. Every sample has the same chance of being picked. Nothing's getting split up into groups before being picked. There's no skipping and there's no convenience involved. It's just pure chance, and that's it. And that's the definition of a simple random sample. So for this one, we would choose simple random sample. All right, looking at example 2, we have a researcher divides a hospital's patients into age groups and then selects a few from each group. So whenever we take the population and we split the population into groups, immediately we should be thinking about either the cluster method or the stratified method. Now, we narrow it down between the two based on, once it's broken into groups, how were the samples picked from there. If entire groups are picked to go into the sample, that's cluster. If you're taking a few from each of the groups, then that's stratified. And that's exactly what we have in this case. We have a case where the patients are split into groups by age, and then a few are picked from each group. So for this one, we're going to choose stratified. All right, let's look at example 3. A factory quality control manager inspects every 10th item coming off the production line. When you hear something like it's every 10th item or every 5th person, that's the signal that we're using a system. We're using a pattern to collect the people or the individuals that are going into the sample. So when we're using a system like this, that's when it's called systematic sampling. So in this example, I'm going to choose option A. Example 4 says an auditor randomly selects 3 entire warehouses and inspects every item inside those locations. So we want to think of these warehouses as groups. The person who is making the sample selection picked 3 of the warehouses and shows every single item in that warehouse. This is cluster. The population of warehouses was split by groups, so each warehouse was a group. And then entire warehouses were chosen, so this is cluster. So I'm going to choose option B for this. Okay, example 5. A student asks their closest friends for opinions at a school event. So, because for students to ask their friends at a school event, that is a very convenient and easy way to collect data. This would be considered convenient sampling. Okay, last example. A manager walks around the office at lunch and picks a few people at random to complete a survey. This here is a random sample, but it's not a simple random. It's not planned in a way that every single person has an equal chance of getting picked. The people that are in the path of this person that's walking around the office has a higher chance of getting picked because he's just walking around the office randomly picking people. So someone that's sitting at their desk on the other side of the room is most likely not going to be picked. So they don't have an equal chance of being picked. However, he is still picking people randomly. It's just not a simple random sampling method. So we would choose option B. All right, so now to wrap it up, let's take a minute and summarize. If every individual in every sample has an equal chance of getting picked, like picking names out of a hat, that would be a simple random sample. If there are subgroups and you take some from each subgroup to sample, that's stratified. If there's a pattern where you take, for example, every 5th person or every 19th item, then that's systematic. There's a system, there's a pattern. If you take entire groups, so you split your population into groups and you pick entire groups, that is called the clustering method. If you, whoever or whatever is easiest to reach for your sample, that's convenience. And then lastly, if you choose randomly, but it's not necessarily allowing for equal chances of getting picked, then you just call that random, but not simple random. So understanding these methods for sampling will help us evaluate how trustworthy or how valid a study really is. So next time you see something in the news, a statistics, you want to ask yourself, how did they collect that data? Can I believe that mean or that average? Can I believe that proportion? Is that true? Did they pick the sample in a way that gave us a good, valid result.